Welcome. In this video, we're going to use this graph of the function g of x given here to explore various aspects of both average and instantaneous rate of change. So the first thing we want to do is find the average rate of change of the function g on this interval from x equals 0 to x equals 1. So that would be here. So if you notice, this is a secant line connecting those points. We want to know, well, what is the slope of this line? So to do so, remember, the average rate of change is the change in outputs over the change in inputs. So the change in g over the change in x. So g of 1 minus g of 0 over 1 minus 0. When x equals 1 here, well, what does g equal? We can go up here, we can estimate. This is about 44. Now when x equals 0, g is 0. So this is 44. Next, let's identify at least one interval on which the average rate of change is 0. Now there's several we can say here from 0 to 5. If I connect these 2 points with a line, that line is horizontal. So that's an average rate of change of 0. Another way to write this is x is in this interval between 0 and 5. And this little backwards e just means inside. All right, let's find another one. And I'll go ahead and sketch this one out. So how about between here and here? Notice I can connect these with a horizontal line. And what is this? This is about 1.8, and I would say 1.85. So another interval is x between 1.8 and, not 1.85, excuse me, 2.85. So there's the second interval. And so on your own, you can identify several. Here's another, anywhere you can connect these with a horizontal line. So even here from x equals 1 to x equals about 3.5 would be yet another. All right, next, which interval provides us with a larger rate of change? The interval between x equals 2 and 3 or 2 and 4? So in order to figure that out, let's connect these. So I'm going to connect that interval between 2 and 3 with orange. So at an input of 2, my output is here. At an input of 3, my output is about there. And let's connect this with a line. There we are. And I'm going to connect this next one with a green line. So here we go. This deep green, and this one had an orange line. So I'm going again from this point, but this time to 4. Okay, so there we are. Now, which one of these has a larger rate of change? You could say which one has a larger slope is another way to word that question. So slope of secant line. The slope of the secant line connecting x equals 2 and x equals 3, that's this orange line here. And its slope clearly seems to be not as steep as the slope of the secant line connecting 2 to 4. If you're struggling to see this, imagine if you're walking uphill on these lines, which is a steeper walk? This is a steeper walk than this. Next, let's compute this difference quotient, then explain what this value represents geometrically. So g of 3 minus g of 1 over 3 minus 1, our denominator yields 2. When x is equal to 3, g has this output here. I would say this is the point about, let's see, approximately 3, 28. And when x equals 1, that would be here. What is my output? I think we already estimated this at 44. So let's explain what this is geometrically, and that will help us make sense of our answer of -8. So geometrically, this represents the slope of this line here in red. Ask yourself, is this a positive slope or a negative slope? It's going downhill from left to right. So we're traveling downhill. So it's clearly negative, a negative slope. And so here's this line here. It represents the slope of that red line. We don't have any ice cream. This is also known as the average rate of change. Hold on. Azalea, I need 2 more minutes. I will give you food, but I need 2 more minutes. Let me just finish what I'm doing. Please. Your bento box is on the butcher's block. Finally, we're going to estimate g prime of 2, that is the slope of the tangent line when x equals 2 geometrically. Now, as you can see, I went ahead and pasted another graph here just because there's a lot going on here. So when x equals 2, here is the point 2, and I would say that's maybe 17, would be my guess for the value of this point. And so let's go ahead and draw a line tangent to this point. Okay, there is my line tangent to this point. All that is left to do is compute the rise over the run. So I can see from here, we go down about 15, and then the run here to this spot is about 0.75, or I'd say 3/4. So that gives us a slope of negative 20. I hope this video provided you with waves of wonder from this whirlwind of wisdom.